In the last video, we went over vertical reflections, but in this video, we're going to go over horizontal reflections. So say, for example, that you just have an XY axis right that. Right, so nice XY plot. Here's your X, here's your Y, and you have a random point, right? I'm going to choose this random point to be, say, 2 and 3. So here's my coordinate right there, and that coordinate is 2, 3. And if I reflect it horizontally, which means that I'm going to reflect it across this axis. And this axis is known, obviously, as the y-axis. So if I reflect this point across this way, my new point will be at -2, but it remains at, the output remains at 3. So this new point is -2. So while the old point had an input of 2 and an output of 3, the new point has an output or input of -2 and an output of 3. So keep in mind, the first thing that we're doing is we are reflecting. Let me just write that again. We are reflecting. Reflecting across the y-axis. And the second thing to observe is that the outputs don't change. Like if you observe, the 3 doesn't change, but the inputs do change. So a horizontal reflection affects the inputs. In other words, it reflects the x's, but not the outputs, which we describe as the y's. And so it's very important to remember that when you're reflecting horizontally, even though you're affecting the x's, we are reflecting across the y-axis, because the y-axis helps us move the x-coordinate from being positive to negative or vice versa. The second thing that we should know is the functional notation. So how do we describe horizontal reflections? And so the way we write it is we write y equals f of -x, right? And keeping in line with this line over here, which says it affects the inputs but not the outputs, if you observe over here, this right here is changing the inputs. All the x's are becoming negative. But the y's, if you observe, this is outside of the f. Well, there's no number here, or no negative, or no positive, or anything. Well, it is positive, but there's nothing changing the y value. And I'm not adding or subtracting anything that would also change the y value. So the y value stays intact. And so again, by writing f of -x, it just makes all the x's negative while keeping the y's intact. Let's do this through an example. And I've been using this example throughout. Excuse me, I just got to erase this thing right here. I've been using this example throughout, and what it is it's the f of x, and there are 3 edge points. It's 1, 2, 2, 4, 2, 4, and this last edge point is 4, 1. So let's say, for example, I have this original function. So this is my f of x, y equals f of x, my original function, and I transform it to y equals f of -x. Well, how will it look like? Well, the first thing to do is you should always just write a description of what exactly is happening from here to here. And obviously, as we said, since the negative's on the inside, there's a reflection across the y-axis, as we mentioned before. So in other words, we're reflecting across this way. So if we're reflecting across the y-axis, remember, it's changing the x's. So what will the new xy plot look like? Well, as we said, since the x's are becoming negative, this will become -x, but the outputs, the y's, stay intact. So these x's, all of these will become negative. So this becomes -1, -2, -4. Whereas the y's, these 2, 4, 1, stay the same. 2, 4, and 1. And now let's plot it. So our first coordinate for our transform function is -1, 2. So here's -1, 2. So there's 1 point. And then there's -2, 4. So -2, and that's about 4. And then finally -4, 1, which is right about here. And then what I'm going to do is I'm just going to connect all these dots through a straight line. So let's say you have this point here connected to that, and that point here connected to that. And finally, what I'm just going to do is just label it. So here, this green line, this set of green lines is f of negative x. And now we can clearly see if this is the original function, and if I reflect it across the y-axis, in other words, if I changed if it was a horizontal reflection, this is what this new transform function would look like. This is effectively just that over there. And we can clearly see there's a reflection across the y-axis. In the next video, I'm going to go over stretching. So in other words, stretching a function. See you in the next video.